Hey there, and welcome to Into the Terminal, episode 35. Can you believe we've already done 35 episodes of Into the Terminal? I am Eric, the IT guy Hendricks, and joining me every episode is my illustrious co-host, Mr. Scott McBrien.
Hello.
So, good morning, folks. Really excited to be with you today. Let's dive in. Today, we're going to talk about application streams. So, some of you may recall back in the RHEL 7-ish days, we had this thing called software collections, which was this concept that was designed to make it easier to install not just a package, but a package, all of its dependencies stay on certain software versions. It was a great idea, and but had some technical limitations. It had some issues with deployment. So with RHEL 8 and now into RHEL 9, we've actually moved to something similar called application streams. So at its core, application streams. App streams are different. Application streams is a concept of bringing in newer versions of software of that are tied to specific life cycles. So your database may run on a different life cycle than your web server. So application streams helps you manage that chaos. Scott, did I miss anything with explaining what app streams are?
No, and a lot of times we have, thanks to Red Hat Enterprise Linux 8's implementation of application streams, we associate application streams with modular packaged software. It turns out that's not always the case. And we'll see in the deeper dive today an example of when that may not be the case.
Awesome. So yeah, so for our critical path today, why don't we install a module and its tied-in application? One of the workloads that Red Hat supports is Node. So why don't we start with that? So first, we need to see what modules do we actually have available. So why don't we do a DNF module list? So it's going to go ahead and pull in all of our metadata. So you see different things here like Python 3.8, Python 3.9, Postgres. There's some Ruby, of course, everyone's favorite PHP. But for today's example, let's do some Node.js. So you notice that you've got Node.js 10, you've got Node.js 12, 14, 16. You've got all these different versions. One thing I want to call your attention to is the brackets with the D inside of it. That means that is the default for our current operating system version. So for we run a RHEL 8 today.
We are running RHEL 8 today.
And we'll explain why here in just a minute. So for RHEL 8, Node.js 10 is the default. We can enable different versions, and we'll talk about that here in just a second.
I figured I'd just pull up the Node.js specifically, since that's what we're talking about.
Perfect. Yeah, yeah, so you've got 10, 12, 14, and 16. So depending on what your application's running, depending on what your needs are, you can actually lock yourself into a specific stream, which is tied to a major version. So next up, so we're looking at the Node.js module list. Why don't we go ahead and install Node.js? So what we're doing when we're doing a module install is we're basically enabling that application stream and then tying in the default version. So if we go ahead and hit return here, we'll go through process that will feel very familiar to everyone. You notice Node.js, npm is a dependency, but you also notice that it was enabling the actual application stream for Node.js 10. So pretty typical to a software update process. And now we'll notice that if we look at Node.js under version 10, we'll not only is there a D for default, but there's also an E for enabled. And the next column over, there's an I for installed. So what this means is we can now manage this system like we would any other system for package management. So if we do a DNF update a few weeks from now, there may be a Node.js 10 security patch or something along those lines that comes into play. But the upside to that is that we won't ever update beyond that major version. We're kind of locked into Node.js 10. which means if you have an application that would break by moving up to 12 or 14, you don't have to worry about that just doing a DNF during your regular patch cycles. The only downside, and this is if this is the only problem, this is awesome, because the only way to move between version 10 and version, say, 16 is we actually have to do a remove on that module. So why don't we go ahead and remove our Node.js module, and then we can install a newer module, which will allow us to upgrade to a different version. So it's going to remove the dependencies, going to remove Node.js 10. And then if we do a DNF module install, we can actually specify the version. So here we can do a Node.js : to specify which application stream we want. We'll go with the latest. So like I said, there's an extra step that's required for moving between versions, but considering the advantages that it brings, it's well worth having that extra step to move between modules. Oh yeah. So yeah, there is an extra step involved where you have to disable the current application stream and then enable the next one.
I think we could probably have done away without the enabling, right? If we actually did an install with the correct version number, it would have automatically done the enable for us. But
so now we can do an install on Node.js 16.
So this is maybe some changes that have happened over the lifespan of RHEL 8. That was not always the case. It was one of the dot releases where they actually made us move the enable flag between before we could actually change it over. All right, and there's our final list.
There we go. Now we've got Node.js 16 enabled and installed. All right, so I do need to give a quick shout out before we go into the deeper dive. Happy Sysadmin Day to all of the sysadmins out there. I think this is like the 25th year that they've done Sysadmin Day. So if you are a sysadmin, thank you so much for all of your hard work, for all the things that you do. In fact, my 4-year-old daughter decided that I needed to have a sticker today. So I'm wearing a popsicle sticker on my shirt, I guess, in celebration of Sysadmin Day. So thank you all for if you do systems administration work, we definitely appreciate you and everything that you do for your companies. So Scott, do we want to talk a little bit more about life cycles and how that ties into the different application streams?
Sure. So first, I mentioned that when we switched to deeper dive, we would quickly round out like the application stream story. So a lot of people associate application streams with modules and with modularly packaged software, but that is not always the case. So application streams can be distributed as just regular RPMs. They can be distributed as software collections, which is a method of modular packaging where the version number is not unique. So you can have multiple versions of the same thing installed in parallel. Or you can do modular packaged software like we saw it with Node.js, where you can pick any one you want, but you only get one. You can't have multiple versions installed at the same time on the same machine. So we actually have a support page for application streams as well, because they do often have a different lifecycle. Reason for that is that there are some pieces of software like Node.js that moves very quickly, but also that the community also moves quickly away from. So typically with Red Hat Enterprise Linux, we want to make sure that we package things that are longer term releases. And that's usually what we pick for things like Node.js. But in the Node.js community, they don't support something for 10 years. They support it for much less than that. And that's reflected in the lifecycle restrictions on something like the Node.js application stream. Others, like Postgres, their community does support versions for a significantly longer period of time. And you can see if we looked at like the Postgres um, application stream lifecycle, there are some that have a very long life in the software package or software catalog, I should say.
So out in the chat and in the show notes below, we'll have a link to the application streams lifecycle page that Scott referenced. Let's see. Do we want to do some more examples?
Yeah. So I saw a question in chat.
Oh yeah. Let me go ahead and pull that up. So ClusterKid asks, will the default module be used if you just run dnf install without specifying the module part in the command?
And the answer is yes. But if you do a DNF module list and you get all the modules out there, you'll notice that for each one that has multiple versions available, that there is one tagged as the default, right? So if you just do a DNF install Subversion, you're going to get Subversion 110 because that's tagged as default. Or if you do a DNF install Ruby, you're going to get 2.5 because that's the version that's tagged as the default. So if you want to go something on that, you need to use that version extension, which is what we did with Node.js 16. And just to refresh your memory, that looked like this. Well, we told it the module software name we wanted, a colon, and then the version that we wanted. So for example, if I wanted Swig 4.0, then for that one, I do a DNF module install Swig colon 4.0. Right? So whatever version is represented in this second column, that's the version number you put after your module name. So Eric, what about looking at a software collection packaged software?
Let's see. Okay. So why don't we do a... Sorry, I can't read today. Let's go ahead and do a module list on Python. Of course, it's going out pulling a module list, and then we're doing a grep just to pull back the Python. Sorry, I started talking over you. Go ahead.
So a module list is still used for software collections as well because it's modularly packaged software. The difference between a software collection and other application streams is that notice in the output, we actually have a different name for each of the streams. And then also notice that each one of them is tagged as default, right? So if I did a DNF module install Python 39 and Python 27, I can have both.
So notice that is different than the modules we're looking at with things like Node, where you can only pick one. But with a software collection like Python 2.7 and 3.9, you can actually have multiples, and then you get into things like defining which version of Python you want to use in say a script or an application. So that's good to kind of keep in mind that those possibilities are there.
Yeah, and Python is one of the special ones, right? Because there are things that the system does that are Python specific, but then there's also things that your application layer may want to do that's a different version of Python specific. And so we package this one so that you could have them both installed in parallel. But as Eric referenced, like all of a sudden there gets to be a whole lot of complexity because when you do a shebang user bin Python, which one is it? So yeah, actually, that's a good question. So the answer is neither. By default, there's Python 2, 2.7, Python 3, 3.6, and I think that Python 2 or 3 is actually a symbolic link. Yeah. And uses the alternative system. So you could have even multiple versions of Python 3 installed, but then when somebody just references Python 3, they can get 3.6, 3.8, or 3.9 according to your system settings to decide which one of those should be used. Or they could use it explicitly by using user bin Python 3.9 or 3.6 to specify which version they want. So it gets complex as a system maintainer to have multiple versions installed at the same time. And that's why only a few of them are like Python as software collections.
So I mentioned at the top of the show that we were actually running RHEL 8 today and not RHEL 9. Why is that, Scott? Did you not get your homework turned in on time?
Well, yes. Although I was telling Eric before the show, I sparked up the machine and was doing, just some sanity checking, and I was like, "Where are all the modules?" And turns out I was looking at a RHEL 9 box, and yeah. So with Red Hat Enterprise Linux 9, the long support versions of things are the base versions in the distribution. And then we'll be adding subsequent modular content starting with the first update release, right? So 9.1 is when we should see the first set of modular content land with 9. And the goal of this is to allow people who are not interested in changing versions to be really simplistic in their method of managing software, right? They just do a DNF install something and it's there and it can be there for the duration of their installation with some exceptions. Whereas people who are interested in advancing and moving to a newer thing, they can choose to do that when it's right for them.
So yeah, keep an eye out for some application stream updates to be hitting RHEL 9 this fall-ish, when 9.1 and 8.7 would already have them in 8.6, but they'll be coming to RHEL 9 this fall with the release of 9.1. So we kind of covered the next points. Default enabled, disabled. We could run through another example of that if we'd like. So yeah, we got a couple of questions around modules and how to enable and disable. So why don't we take a look at something similar to our earlier example and cover Ruby. So if we do a DNF module list Ruby, we can see what all's there. So our default is actually 2.5. So if we did a DNF module install, we'd get 2.5. But maybe when you wanted to go with something a little bit newer and say go with 2.7. So for that, we can do a DNF module enable. And actually, why don't we test your theory? What if we do an install and skip the enable? I think we could do a module install Ruby 2.7.
It would work and it would do both. It would install it and enable it. But the reason I broke it out separate in our show notes document is because I want to talk about something specific.
Sure.
So we saw that when you installed the default version, to switch to something that was not the default was like several steps. So what if instead, if you wanted to target all of your systems to default to Ruby 2.7, why not just run a command across all of them that enables that module, right? So now, if we take a look at the list, Notice that module 2.7 is enabled, but we have not yet installed it. So let's do a DNF install Ruby. Notice I didn't specify the version number. And look at what version we're getting. So if you wanted to set it up so that your population as a whole, if someone did a DNF install Ruby, they got 2.7, then you as the administrator of the system could just enable that module across your population, and then your individual users or your individual other system administrators don't need to worry about specifying the version number. They just do a DNF install Ruby and they get the right version that you've enabled across your population.
Well, and looking at the dependency list brings up another good point. By locking into a specific application stream, all of the plugins and all the libraries and everything that go with that particular programming language come with it. So, like, I think Ruby's one with Ruby gems. There's a few other programming languages blanked off the top of my head, but that have a very, very strong ecosystem of plugins and modules that can be added onto the top of it. And so you don't want to install Ruby 2.7 and then install a gem that is dependent upon a newer version. So by using an application stream and only enabling the stream that you want to lock into, you get all of the dependencies are locked in that same stream as well. So the chat's pretty quiet today, and so was our list of examples. Scott, is there anything else we want to cover?
No, I think that covers our programmed content. Don't forget to like, and if you think somebody would enjoy this content, share it with them. And if you want to be notified that we're doing this in the future, hit that subscribe. I did notice that Max Bartlett had a question about a different DNF command. So Max asks, what's the difference between DNF update and DNF distro-sync? And I actually had never used distro-sync before, so I did a little bit of quick research, and it looks like they kind of do the same thing. It just updates all the packages. But it would not let you, like a DNF update lets you specify individuals, whereas distro-sync does everything that's available for the system. So it's kind of like a yum update with no options. Realize that DNF or yum update also allows you to do things like apply security updates with the security plugin, and then things like modules and a variety of other things too. So distro-sync is a large hammer. If you are in a more complex environment, it may not be the thing that's most appropriate for your complex environment.
And then, of course, our buddy Eighth Doctor's hanging out with us today. So he says that DNF distro-sync ignores EVRs and syncs your local packages to the latest version enabled in the repo. And the DNF distro-sync supports scoping to specific packages as well. So, Max, hopefully that answers your question. If not, by all means, we can continue the conversation in the comments below. We do check all of our videos on a fairly regular basis to make sure that we're getting questions answered. So definitely a growing community around the into the terminal group of folks. So thank you all for joining us today. We'll wrap this one up a bit early, but on behalf of Scott McBrien, myself, and the entire Red Hat Enterprise Linux team, happy Sysadmin Day, and thank you all for joining us live. We will see you next week when we talk about SSH keys and how to manage access between systems using public and private keys. So until then, thank you so much, and we'll see you next time.
Bye, everyone.